the ocean off Key West, Florida. I'm here with Dr. Ellen Prager, a marine scientist who's published a number of books, and we are in the Aquarius underwater habitat, a one-of-its-kind facility here, anchored 50 feet down, permanently here, that allows scientists to study the coral reefs, the fish, and the water of our oceans 24/7. Unlike normal scuba diving, where you can only go down for a brief period and have to surface for more air and to change pressure, here scientists can live much like they live on the space shuttle. To give you a sense of what the pressure is like here, I'm sure all of you have had a can of Pringles. I don't know if you can see this can of Pringles, but we're at high pressure here, about 2.5 times the pressure of what you would have at the surface of the water. Here is a bag that was filled with air when we were at the surface. That pressure is on our bodies right now. If we were to surface too rapidly, we could actually get sick. But this vessel that we're in right now allows scientists to stay here for an extended period of time. We're going to talk in a little bit and answer some questions, and we may have some visitors in a moment. But other than the fish, I have a friend who's going to swim by and say hello. But before we do that, let's take a quick tour, and we've got some video of what this wonderful facility looks like so you can see exactly where we are. Sound good, Ellen?
Sounds good.
Hello, my name is Dewey Smith, and welcome to Aquarius. I'm one of 2 habitat technicians. My job down here is to make sure that the aquanauts are safe, healthy, and being productive down here, and we'll have a successful mission. We're going to start the tour here, as you see, in the bunk room. These are where the 6 aquanauts sleep. It's pretty close and cozy, but it does the job. We don't spend much time in here, so there's a lot of space. This is where we keep all of our clothes and goodies and books for the cruise here. If you look forward here right underneath the viewport and right underneath the grouper, we do have a workstation here. It's a fold-down station with a laptop with internet capabilities. And that's for anyone to use. And we'll go ahead and come on out here into the main lock. And over here to the right here, our starboard side, we're actually looking towards the bow, or through the bow to the bow of the habitat. And on the starboard side, starting as a camera, which the watch desk has a constant eye on us 24/7 during a mission. We do have another workstation here. This is for me and the other habitat technician, Buckley. And this is where we have a live chat to the watch desk, so if anything happens, we have a live chat to them, as well as a barrage of phones. We have digital, landline, cell phone. And as we carry on through here, we have a depth gauge here, which shows us that we are at 47 feet of salt water. We have a bunch of monkeys here also. Some of the aquanauts, we got aquanauts coming back from a dive. They're eating and getting their meals ready, getting warmed up after the dive. Underneath that depth gauge, we have our sensors that show the oxygen, temperature, humidity, CO2, and CO readings and alarms there. Further back, we have our air distribution. This is where we get our atmosphere makeup. We have a 30 cubic foot bleed going on right now, and followed by our electrical panel, which has a bunch of buttons and switches there. That's how we get lights, camera, and action. We have another station here with another computer that also has Internet Connect. Back on the other side, to the port side, we'll see people eating, enjoying the loads of food that we have down here. We have a regular sink and utensils and a microwave like you would at any kitchen. And we'll carry on through into the entry lock. And we'll see another couple aquanauts here hiding out. You can't run from those guys. We'll also have the same thing as I pointed out in the main lock. It's mimicked here. The electrical panel, air distribution panel. Right on. How'd the dive go, guys? All right. Good deal. No problem at all. All right, and this is a final space here. It's actually where it begins is in the wet porch. And the camera may fog up on us, but we'll try to keep it clear for you so you guys can see what's going on in here. This is where the power and air come through into this space right here. We have an air distribution panel, as we saw in the main lock and entry lock. This is how we distribute it inside. And if you can see through these, you can see the moon pool. We do have some gear drying. This is where all their gear is staged. This is where we stage out and do our dives and all the work. This is why we're here. The shower is a small space, but it gets the job done. Hopefully you can see that. And there's also another camera in here that is a direct link to the watch desk, and they can watch us from here too. Thank you for joining us. We'll go ahead and sign out. And thank you for listening and watching, and we will see you guys soon, hopefully out in the water. Good night.
How did we get here? Well, we are now in dry clothes, but we actually scuba dived down here with tanks and fins and masks, but we left it outside the vessel. The vessel is kept at the exact same pressure as the seawater. If you want to do an experiment in your class or at home, take a glass of water, turn it upside down, and as you put it in the water, you'll see that the air inside the glass raises up because the pressure of the water is compressing the air. Inside this vessel, we have compressed air, and that's how we're able to live underwater. Believe it or not, the door is open, but air pressure is keeping the water out.
Yeah, if for some reason that air pressure was to be reduced, the water would start flowing in. Not good.
Not a good thing.
Not good. But one of the things that's really terrific is that you take off your scuba gear and you actually go right from the water, you climb up the stairs, and there are fish swimming around your feet, and yet you're in air at 50 feet down. How cool is that?
And we're looking out the window here, and you see fish swimming by, and later we'll have scuba divers. We have people from Wahkiakum High School, Wishram Elementary, Wishram High School, Skyview High School, Hawkinson High School, and Napavine. Ellen, you're the expert at some of this. What types of, Savannah from Miss Keller's Napavine Elementary School.
Hi, Savannah.
Wants to know what types of species commonly rely on healthy reefs, and you've written some fantastic books on this.
Well, thanks. Well, you know what? An easy way to find out, I just have to look out the window. Actually, there are quite a few species. In fact, thousands of marine species of fish, crustaceans,
which are
sea
shellfish,
stars,
right?
shellfish, sea stars, all rely on the reef for a number of things. For a home, places to live. They rely on it for food. And let's see, what are some of my favorite things? Well, if I look out here, I can see we just saw a sergeant major fish go by. I like to call them the feistiest fish under the sea because they very aggressively protect their nests. And they have black stripes, 5 black stripes that run down their bodies, so that's how you know them. But we regularly see groupers, snappers. Oh, and there's a very new species, just I can see out the viewport coming by. I think it's of the human variety. But there's also octopus and squid. All of those species use the reef. Oh,
here's a
very
friend of mine.
Strange species.
This is a colleague from Congress, a guy named Mario Diaz-Balart.
Can he see us?
He can't see us. We're going to peel this back a little bit.
We have a very special film on here for the camera.
He's a member of Congress from Florida. We serve on the Energy and Environment Subcommittee together. He's diving outside. I think you can see him looking at us, waving at you. He's a representative from the state of Florida, and he's letting us know that he's outside. You can see where he's a diver. He's going to swim around now and look at some of the other fish. So that's another species we find.
Another species, but I think, you know, one of the really neat things about the Aquarius is it sits in a research-only site. There's no fishing, commercial diving, and so the habitat itself actually acts like an artificial reef. So there's a huge number of fish, a diversity of species, all swimming around, and so he's out there not only looking in, he's looking at all the wonderful marine life out on the reef.
A couple other questions here. We've got some folks from Wahkiakum High School in Cathlamet want to know, you know, as we know, Cathlamet's on the Columbia River, Ellen. It's a beautiful, beautiful community, a lot of fishing there. And one of the questions is, what have we learned so far from Aquarius that can help us in our own community in Cathlamet and the Pacific Ocean? This, of course, is in Florida. What do we learn from here that can help us understand the ocean and the river out in the Pacific?
Oh, that's a great question. I mean, obviously, what I was just talking about is one really good lesson about if you have a site and you protect it, you protect the species and you allow for abundance and diversity to grow in that area without harm. And so that can be done anywhere. You can create protected areas to preserve the species that live there over time.
And you know, fishermen, commercial fishermen have come to appreciate the value of protected areas because this is the rearing area where fish can reproduce and create their numbers, so the commercial fisheries can benefit actually from protected areas.
Well, and one of the things that scientists have discovered is that if you have a protected area, it's not just within its borders that you benefit from, the species actually spill out, like you might see the abundance of fish spill out into the neighboring areas, and so that's really important. Here we've also learned a lot about sponges, which is very, sponges.
We've got a lot of sponges.
We got a lot of sponges, and people think sponges are sort of boring, just sit there. It turns out that they can seriously pump water through their systems, and that's how they get oxygen and food. One group that's been working here for a while has discovered that one big barrel sponge, something like that big, can pump the equivalent of an Olympic-sized swimming pool in volume through its body.
Amazing.
And so they have a big influence on the chemistry and the quality of the water on the reef.
Part of the reason we're especially interested in this facility is it's been here over a long period of time, and we can see changes. With the recent oil spill in the Gulf of Mexico, one of our questions will be, how does that oil and the dispersants that were used, how will that affect the reef system and the aquatic environment here? Let me ask you another question, Ellen. One of the questions is, how long do scientists stay in the research facility before they go back upstairs and up to the surface, I should say?
Well, it varies from mission to mission, but typically they stay down here for about 10, maybe 14 days at the most. And the advantage of living in Aquarius, not just because it's cool to live underwater,
which it is,
but it gives scientists, say, 5 to 9 hours a day diving. And if you were diving from the surface, maybe you'd get an hour at most during the day to do your research, maybe 2. But imagine 9 hours to do experiments, collect samples, and do surveys, just as the Congressman
and
was
night
saying.
and day. You can go out at night and daytime as well. Even in terrible weather up top,
right,
you can be fine down here.
And one of the really important points that you mentioned was long-term studies. With climate change and the world around us changing, this site, they've been studying here since 1993. And so to be able to go back to the same place and do very detailed surveys or experiments over time is really important for us understanding how these reefs and reefs across the world are changing.
One of the things we've looked at, I actually wrote legislation to address this. As carbon dioxide goes in the air, not only does it keep the climate of the Earth up, but it makes the water more acidic. And the question asked earlier, how do what we learned here at Aquarius help us back home? More acidic water dissolves the minerals that shelled organisms need to make their shells. Back home, our oyster growers in the Willapa Bay, for example, are seeing 80% mortality of their oyster seed as more acidic water upwells, and that dissolves the shell. Well, just a few months back, there was an effort here at this very research station to look at ocean acidification. That information is directly applicable to the challenges we face back home.
Right, and just if I may add to that point, one of the other things that scientists do here is they test technology, because they can come down here and look at how it's working. So some of the equipment that scientists bring down here to test can be then used at places like in Washington State to measure similar properties. So this is a great place where people can test technology and see if it works, and they can fiddle with it to change things while they're actually living underwater. And